All right, welcome everybody. Thanks for joining us today for our joint New York and New Jersey Clean Cities Coalition Bipartisan Infrastructure Law Planning Tools and Resource webinar. This webinar will be recorded, so we ask everyone to please make sure that you go on mute. At the end of the webinar, we'll have time for some Q&A. So please, throughout the webinar, feel free to add your questions in the chat. You'll also have the opportunity to raise your hand at the close of the webinar. A recording and the slides will be posted on the Empire Clean Cities webinar or website, and we'll also send a link out to all attendees and registered participants. I'm just going to get started with a quick overview of the agenda. We'll start with just a quick overview of who Clean Cities, what the Clean Cities program is and where we're located, and a little bit about what we do. Then we'll dive into the federal infrastructure funding and what it could mean for New York and New Jersey. And then we'll dive into some of the great resources and tools that are available at some of the national labs, as well as the Center for Sustainable Energy. And then we'll move into the Q&A portion of the webinar. So just to get us started, for those of you who aren't familiar with the U.S. Department of Energy Clean Cities program, it is a program out of the DOE's Vehicle Technology Office. It has been around for about 30 years, and there are it's made up of a national network of 75 Clean Cities coalitions throughout the country. So we have a presence in almost every state, and we're made up of both regional, local, city-specific, and statewide coalitions. Together, since the start of the program, we've helped collectively place over 2 million alternative fuel vehicles on the road across the country, as well as thousands of infrastructure. In New York State, there are 6 Clean Cities coalitions. I am the executive director of Empire Clean Cities, and we cover New York City and the Hudson Valley. We also have a coalition in Western New York based in Buffalo, Rochester, Central New York based in Syracuse, Capital District based in Albany, and a coalition on Long Island. The New Jersey Coalition, who are our co-hosts on this, they make up the entire state of New Jersey. A little bit more about Clean Cities. Again, cumulatively, we've helped with local project partners to reduce petroleum consumption by more than 13.5 billion gallons and counting. It's also an incredibly cost-effective public-private partnership where we are able to leverage an additional $8 for every single federal dollar that's invested in the program. A little bit about what we do. We help connect fleets and fuel providers, industry partners, and resources. So a lot of times we like to say that we are a matchmaker. So we help connect the folks that are implementing the tools and policies and vehicles on the ground with providers, as well as help to identify some funding opportunities and incentive opportunities for municipalities, for fleets, for individual drivers. We also offer training and technical assistance. So anywhere throughout your journey of installing EV charging infrastructure, alternative fuel charging infrastructure, or transitioning to alternative fuel vehicles, we can help throughout that process. We also provide education and outreach to decision makers, fleets, and the general public. So similar to webinars like this, we also do a number of in-person events throughout the year, and I highly recommend that you sign up for our newsletters to keep up to date on when those occur. We also help to collect and analyze regional data. Many of you may have been contacted by us in the past to collect your alternative fuel pricing reports that get compiled into a national report that's published on the Alternative Fuel Data Center, which we'll hear a little bit more about shortly. We're also part of a couple of national DOE-funded EV data collection studies, which is compiling data from fleets, individual EV drivers, and infrastructure operators to create a comprehensive nationwide data analysis that helps to identify gaps in technology, different use cases across different climates and geographies and hosts. And so if you own or operate currently an EVSE station, or if you have electric vehicles in your fleet, please contact us because we'd love to have you as part of both of those studies. And finally, we do help support alternative fuel corridor planning for our municipalities and state DOTs. And so we'll talk a little bit about that shortly, and that's part of the reason that we're here today. So we look forward to helping you along that planning process. So next, I would like to introduce Chuck Feinberg, who is the Executive Director of the New Jersey Clean Cities Coalition, as well as a principal at Greener by Design Consulting. Without further ado, Chuck, take it away.
All right, thank you, Joy. And good morning, everybody. Joy, I tried to turn my video on just to show my face, but it's telling me that the host won't allow it. But that's okay, because nobody came to see me. Good morning, everybody. I'm happy to give this presentation today of an overview of the Bipartisan Infrastructure Law. As most of you probably know, it is a significant achievement of the Biden administration to get this accomplished. Joy, next slide, please. The infrastructure bill itself is actually called the Infrastructure Investment and Jobs Act, but it's commonly known as the Bipartisan Infrastructure Law. This is a $1 trillion+ package, which is historic in its size and breadth and the number of sectors that it touches. It allocates funding to more than 350 distinct programs across more than a dozen federal agencies. And the guidebook that is supposed to be the how-to on how to accomplish this and how to interact with the new programs itself is 400 pages long. So with that, I apologize in advance for what could be a somewhat dry presentation. But when you're talking about what's in a 400-page guidebook and a program such as this, it's kind of hard to make it exciting. While the funding is certainly exciting, talking about the details of it may not be that exciting. Next slide. Given the breadth of the program, our focus today is actually on two of the programs that are most relevant to what we do at Clean Cities. One of those is grants for charging and infrastructure for corridors. As you can see, there's $2.5 billion that are in the programs for this program. And this is for alternative fuel corridors that encompass electric, compressed natural gas, propane, and hydrogen fueling infrastructure along these corridors. And the big program that I'll spend most of the time that I have is the National Electric Vehicle Formula Program, which is commonly known as NEVI. This is a $1 billion a year program for each of the next 5 years. And I'm also going to talk a little bit about the new office that was formed under this program, which is a combination of Federal Department of Transportation folks and Federal Department of Energy folks that will be providing technical assistance throughout the program. Next slide. So just to talk a little bit more right now about the Alternative Fuel Corridor Program, and I will be speaking more about this a little bit later in the presentation. This is formally Section 11401. It's a discretionary grant program. Again, $2.5 billion for multiple fuels. A lot of talk about the infrastructure program is about electric vehicles, and rightfully so, but the corridor program does include all fuels. And the focus is on developing alternative fuel corridors, and 50% of the funding goes to the corridors and 50% is for other community funding. And as you see here, Eligible entities are state and local governments, MPOs, and transit board authorities, as well as tribal communities. Next slide. So the NEVI program itself is a $5 billion program. And I'm not going to read the slides. I'm going to go through this fairly high level. There is a program guide just for this program. And the whole idea of the program is to establish an interconnected network across the country of electric vehicle charging infrastructure. And the idea is to provide a seamless customer experience that is convenient, reliable, affordable, and equitable. And equitable is a big word there that we'll talk a little bit more about in my presentation, and we will hear more about as we go forward in the webinar this morning. And the key to interacting with the NEVI program is the state EV infrastructure deployment plans that need to be accomplished. And that's what we're going to talk a little bit more about right now. Next slide. So again, the idea of the program is to provide confidence to electric vehicle drivers, personal drivers as well as commercial, in all classes of vehicles that drive long distances, and they expect to have reliable access to charging stations when needed. And the funding under this program is directed to designated alternative fuel corridors. That is key right there, and that's where these two programs kind of interconnect. And the idea, again, is to build out the network along the interstate highway system. And only when the program is fully built out, when the national network, when the network within each state along the designated corridors is built out, that funding may be used on any other public roads or other publicly accessible locations. And I'll talk more about that, but that's a key factor right there too. Next slide. Important dates to keep in mind in the program. The program guidance was issued on February 10th, and round 6 of the alternative fuel corridor requests for nominations, that's what the RFN means, request for nominations, that was issued on February 10th. Those nominations, those requests are due to be submitted by May 13th. And also by May 13th, minimum standards and requirements will be published. And they seem to be on track for these dates, and I think those dates are going to be important. Those state plans that are due under the NEVI program are due August 1st. And by September 30th, the FHWA will be in a position to approve those plans. So next slide. The funding, again, just to give an overview, a high-level overview of the funding that's available, it's $5 billion for each of the fiscal years 22 through 26. For FY22, the current federal fiscal year, $300 million has been allocated to the new joint office. And 10% of the funding that's available is for discretionary grants within the NEVI program. And there is an 80% cost share for projects that are funded under the NEVI program, which means the feds will provide 80% of the cost, but state and private funds need to come up with the remaining cost share. Next. So for the current federal fiscal year, again, it's $1 billion. 300 of that goes to the joint office. 70 million of it goes to these discretionary grant funds. $15 million for the operations at the FHWA, which leaves $615 million available for the states under a formula program. And I do not pretend to understand the formula, and I am not going to try to explain it to you. But next slide, the bottom line is that the state of New Jersey is getting about $15 million under this formula program, and the state of New York is about 26 million. So pretty significant funding that will be available through this program. Next slide. So again, this funding is intended to create a national corridor, a national network of EV charging stations that will be built along designated alternative fuel corridors. And those corridors are prioritized along the interstate highway system. So as part of the alternative fuel corridor request for nominations that is currently on the street, states should consider nominating additional corridors to the ones that they already have. And if they don't have any, they should certainly look at. I know New York and New Jersey does have multiple corridors that have been designated, and that is a key factor. You know, when these alternative fuel corridors program first came up, I was asked multiple times, you know, why bother getting designated as an alternative fuel corridor? Because originally there wasn't any funding available to make that designation, to go through that process. And I said back then, this was a few years ago, that, you know, eventually there will be funding available for designated corridors. You have to go through the process. Well, here it is. So that the funding is here. And this is the connection right here between the NEVI program and the alternative fuel corridor program. Next slide. So as I mentioned, once a state determines that the corridor is fully built out, and I will mention what that means, the NEVI funding could be used for other roads within that state as long as they're publicly accessible. The FHWA has to certify that they agree with the state that the corridor is fully built out. And one caveat is that no determination that a state is fully built out will be made during the first year of the program. Next slide. To be fully built out, and this is important, and this is a big change in the definitions. So pay attention to this. EV charging infrastructure is installed every 50 miles along the state's interstate highway system, and it has to be within 1 mile of the interstate. So that seems straightforward, but when you think about it, there's a lot left to interpretation there. And from my conversations with the Joint Office and others, they're going to be fairly liberal in how that's interpreted. You know, for example, often on many interstates, there's a rather long exit ramp. You know, where does that 1 mile start? Does it start at the start of the exit ramp off the highway, or is it at the end of the exit ramp? One mile is not a whole lot of territory. So details like this have to be worked out, and they are being worked out by the Joint Office. And when the states are developing their program plans, they should be in touch with the Joint Office to make sure that details like that are worked out. Another big change is the 150 kW minimum capability of each port of the charging stations. And there has to be at least 4 ports available, a total of 600 kW that could do 150 kW simultaneously. That's a lot of power, and it's not going to be inexpensive to build these systems, but this is what has been determined is necessary going forward into the future to have a reliable system. And there will be limited circumstances where discretionary exemptions will be done, and those will be done on a case-by-case basis. Next slide. So again, the state plans have to be in by August 1st. As I mentioned, the states need to work directly with the Joint Office. They have already started that process. They are available. This is what they are there for. Technical assistance to make sure that these plans can be approved by September 30th, as is the plan. Next slide. A big piece of these plans is going to be equity considerations. I don't know, next slide, please. I don't know how familiar folks are with the Justice 40 initiative, but this is new guidance under the program, under all federal programs, that at least 40% of the benefits of the federal funding has to go to disadvantaged communities. And as part of the development of the plan, the states and other stakeholders need to engage with rural, underserved, and disadvantaged communities to assure that their views are heard in these considerations. And I might add that that is a great opportunity to involve the Clean Cities coalitions in your communities, because we're kind of the boots on the ground and have a lot of these relationships already, and we're set up to do this sort of outreach and engagement. And the DOT and DOE have developed the EV charging Justice 40 mapping tool, and other tools, which of course we'll hear about more as we go forward. Next slide. Eligibility for the program, for the funding. The funding can be used for acquisition or installation of EV charging infrastructure, operational assistance, development activities, signage on site at the premises of the infrastructure, data sharing, traffic control devices, and directional information, and other mapping and analysis tools. Next slide. Just a real quick note about the joint office, and I should add, I give my appreciation to Mike Scarpino, who is currently with the joint office. He's with the Volpe Center, but he's on deployment, I guess, to the joint office. He initially developed these slides, which I've modified. But the joint office is again, it's, oops, there goes my alarm. $5 billion for the NEVI program, $2.5 billion for the corridor program. They're also going to be working on the low and no transit bus deployment program, and also supporting the electric school bus deployment. So they will have their hands in a lot of things, and they will be a key office to get to know. Just a couple more slides. Next slide, Joy. Just real quick again about the alternative fuel corridor request for nominations. The nominations are due May 13th, and the selections will be made by the end of June. And this is the corridor program has been modified so that it aligns with the NEVI program, with the definitions of the EV charging that I just mentioned. Next slide. And just real quick, skip one, there it is. So we talked about the changes to the electric vehicle piece of the corridor. The hydrogen corridor increased from 100 miles to 150 miles between stations. CNG remains at 150. Propane is now limited to fueling infrastructure only for medium and heavy duty vehicles. And again, there will be exceptions granted. And next slide is my final slide. And with that, I thank you all for your time and attention. And I'll turn it back to Joy for the rest of the program. Thank you, everybody.
Great, thanks so much, Chuck. A lot of really great information there. Again, we'll be sharing these slides so that you can take another look at them. And please feel free to put any questions you have in the chat. If there are questions about the funding and about the programs that we aren't able to answer during the Q&A section, feel free to send those over to us in an email, and we can help to find those answers for you. Next up in the program, we're going to dive into some of the available tools and resources that can help you plan how to spend these funding and how to map out your alternative fuel corridors. So first up, I would like to introduce our friends at Argonne National Lab. Joanne Zoe and Marianne Mintz are both principal analysts at the National Lab, and they will be explaining a few of the great emissions, equity, and employment tools that they have developed that can be useful as you develop these tools.
Thank you. Can you hear me?
Yeah.
Okay, great. Yeah, I'll introduce some of the tools that can help you to do the planning in terms of quantify the emissions, also taking infrastructure siting through an equity lens, and also quantify the employment impact of deployment. Next slide, please. So I will start with A-Fleet, but I know most of you guys are very familiar with the tool, so I will more focus on other tools today. A-Fleet is actually mentioned in the infrastructure bill that encourage people to use it to quantify the emission of infrastructure deployment on the site base. One thing I want to emphasize, try to give a very good overview of the bill and also the NAVI program guidance. I want to emphasize that the bill actually cover not only the electrification, but also cover other alternative fuel, including natural gas, hydrogen, propane. And A-Fleet is a tool that cover all this technology and cover both the light duty and heavy duty vehicles and the infrastructure support. The tool is available on the link that are available on the slides, and feel free to let us know if you have questions using the tool. Next slide, please. So this is the EV infrastructure charge infrastructure Justice 40 map we recently developed for the Joint Office. So we know that Justice 40 initiative established in January 2021 by the Presidential Executive Order 14008 state the goal that at least 40% of overall benefits of certain federal investment should flow to the disadvantaged communities. So the interim implementation guidance for the Justice 40 initiative released in July 2021 identified clean transportation as a Justice 40 covered program and identified access to electric vehicle charging station as example benefit of the covered program. So consistent with this Justice 40 interim guidance, the U.S. Department of Transportation and the U.S. Department of Energy developed this joint interim definition of disadvantaged community for the NAVI formula program, which Chuck also gave a very good review. So in order for the states or local agencies to apply for the formula program, they could consider the definition that the DOT and DOE put together to identify the disadvantaged community. And this joint interim definition used all the public available data sets that capture vulnerable populations, also their health status, transportation accessibility, and burden, energy burden, fossil dependence, resilience, and environment and climate hazards areas. So if you go to the link ended at the slides, you could see all the definitions and also the reference they used for each of the data layer. This website is public accessible. And if you go to the website, you can see all the layers on the website. When you click the icon on the top left or top right, here showing some example mapping layers. The first one is public EV charging station without Tesla. Since Tesla is proprietary, only Tesla models can get access to it. We also have the FHWA EV corridor around 1 to 5. So once the 6 is decided, it will be added to this tool as well. The definition of the disadvantaged community also including all the tribal lands and all the US territories. So all together and combine the definition from DOT and DOE both. So all this together that you can see, this is the shaded areas are considered as the disadvantaged communities. On this website, we also have other data layers, such as a substation. So that will help the state agency to plan for the EV charging station if they want the station to get close to electric substations to ensure that enough capacity. Next slide, please. So some of the data layers that will contribute to that NAVI Justice 40 EV charging map are coming from this energy zone mapping tool that Argonne is lead working with other national labs together. The tool was originally founded by Department of Energy Office of Electricity. It's a public web-based mapping tool. So everyone can go to the website and access and register account, and you will get access to over 300 different data layers. The tool originally was designed for power plant planning, but since over the years, we have been adding a lot of different data layers, and now it has been heavily used for charging infrastructure planning as well. I will have a following slide to go to details of the data layers that is especially relevant to the EV charging EV charging station siting. but in general, there's 4 different high-level data layers. One is energy resource, for example, the location of a substation, a power plant, and also solar or wind energy potential. There's energy infrastructure, including charge infrastructure. There's a lot of demographic factor, including equity factors. There's a lot of reference data that coming from different public databases. So again, Argonne is using the EZMT, working with other labs to help supporting several DOE funded, DOE and DOT funded electric vehicle public charging projects. Next slide, please. So give one example, one set of data layers focus on the EV and the transportation mapping layers. As you can see, here's an example showing the Northeast area, the Washington, DC to Baltimore. And the example layers, again, this is just example layers. We do have a lot of layers that are associated with EV and transportation infrastructures. So we have airports, all the alternative fuel stations, not only the charging stations. We also adopt traffic data from DOT. We have the designated fuel corridor from FCWA, and also the EV charging station can be separated by charging level. We also have the major roads, the marine ports, and the public transit stop densities. And since this is a GIS-based tool, so for example, the Navi guidance said the station should be at least 1 mile, travel miles within the heavy corridor. And the GIS tool actually allow you to set a 1 mile buffer on both sides of the EV corridor or the non-designated corridor to see which area that is covering. So again, this is example layers, and this is a tool that you can get access to all these public data sets, and you can use the GIS function in order to plan for the locations that satisfy the Navi guidance, but also aligned with your mission and objectives. Next slide, please. So in the years, we have added a lot of equity layers to the EZMT. We adopt 28 equity metrics from EPA's EJ Screen 2020, so including their demographic factor, air quality factors, and environmental indicators. We have all the sensitive areas identified by EPA. We also added a lot of data layers from the sensors, such as a household without vehicles or number of households living in the multi-unit dwelling. Also the opportunity zone from the HUD, which is another federal data sets. There's a lot of other information I don't need to read it line by line, but I do want to point out that it also included transportation energy burden, which is one data analysis we have been doing for Department of Energy to quantify at a household level how much of their income has been spending on the vehicle fuel to support their transportation needs. So that's an indicator for people to find a community that suffer from a high energy burden and could benefit from the transportation electrification, not only on the environmental impact, but also reduce their cost burden at household level. All the mapping layers can be viewed and curated on the map on the EZMT platform, and you could download and adopt them into your own mapping tool as well. Next slide, please. There's some other relevant layers I want to point out. Since this is funded by Office Electricity, so it has very rich data related to the grid. It has the electric substations, transmission line, the power retail service territories, including all the power plants. It shows the sensitive areas or environmentally protected areas such as national park and land cover. We also added all different kinds of schools or MSI into the EZMT right now. So this is really useful data layers. For example, the transmission line, the substation can be used to give you a reference that if you want a high charging location, high level charging station located in certain census tract that you want to be close to a substation, that just give you the idea that where the substations are. And also for the designated corridor, some local agencies like to leverage the corridor as education property for the minority student from the MSI, and this school, college, university layers can use for you to identify the location of those schools, and especially the school, within 1 mile of those highway corridors. So you satisfied several criteria. Next, please. Okay, I mentioned the transportation energy burden. So this is the data sets that we had in the EZMT. So at the national level, the percentage of household income spent on a vehicle fuel is about 3.4%. However, in some census tract, that percentage can go up to 23%. And this map showing the energy burden by census tract across the U.S. And we have a zoom in map to Illinois. As you can see, people knows Illinois that you can see on the top left, that's Chicago, and a lot of the southern area that is rural actually has a much higher, those households are suffering a much higher energy burden. And we found out that the vehicle efficiency is one of a key indicator of the transportation energy burden. Improving the vehicle efficiency, for example, promoting the electrification will be a good is a good way to reduce the household burden, energy burden. Next slide, please. I'm almost done. So we are using those analysis, for example, the energy burden and also EZMT supporting Department of Energy right now to help identify the locations that better to have a charging station for the disadvantaged community. This is an example that is showing that if we use EZMT, choosing the census tract has suffering from high energy burden and have a very limited access to public charging stations. So the metrics we use here is from the center of census tract and go 15 minutes of driving, you have a less than 10 public charging stations accessible. So an overlay with the transportation energy burden that you can see, I have a zoom in map of New Jersey and New York, that you see which census tract, which community actually qualified for the criteria you set it here. Again, the map on the right is just showing you that from each census tract, we can quantify how many charge stations accessible within 15, 30, and 45 minutes. Here, we're using 15 minutes of driving. Please note that for urban area and for rural area, different type of threshold should be considered for the time of driving. Almost there. Next slide, please. Another metrics we used for supporting Department of Energy in identify this disadvantaged community is to identify the community that will be impacted during the clean energy transition. So we want to quantify the community that primarily, for example, here, identify the community primarily based on the fossil fuel production and how we can help them to shift toward to clean energy production. So we'll be able to identify the community based on their job and occupation type, and also the accessibility to those jobs. So here we are showing the states in the north, in the southwest, and by community, this is the number of jobs within 45 minutes of driving from each central census tract. So this is the community that will impact and at risk of the energy transition. However, they also have the skill sets for the clean energy job opportunities. For example, the geothermal energy production would require the same skill sets. So this one helps the decision makers to quantify, to first identify the community and help them to join the transition period. And again, we will also need to quantify what is the job impacts once we have a clean energy infrastructure in place. I think this is a good transition point to Marianne that I can talk about our jobs tool. Next slide.
Can you hear me? Joy?
Yeah.
Oh, good. Okay. So I am going to switch gears now and talk about employment. And interestingly, in Chuck's comments, the BIL is the Infrastructure Investment and Jobs Act. So that's an important topic as well. And also, as both Joanne and Chuck mentioned, $2.5 billion in the legislation is directed towards not just electric vehicles, but also other alternative fuels. So I'll talk a little bit about that, although I will be focusing primarily on electrification. This first slide is a screen capture of the website for the jobs models. And as you can see on the right, there are 4 of them. Jobs EVSE, which is the new one, which looks at electric vehicle supply infrastructure. Jobs H2, Jobs NG, and Jobs FC. The NG tool, natural gas tool, is specifically it specifically addresses natural gas fueling. And that has been updated, and it is, as I said, available on this same website. Jobs H2 is hydrogen fueling, and we're in the process of updating that model. It was originally developed several years ago, and we're updating it with new data on costs of hydrogen infrastructure, and the same thing for Jobs FC. So those 2 will be updated in the next couple of months, but right now they're still the older versions of those models. And this, as I said, is the website. I don't okay, there is the link is at the lower right-hand corner. And next slide, please. Now, this is an overview of the approach that's basically taken by all of the jobs models, but this particular slide focuses on electrification. So we start off looking at what is the infrastructure that's actually on site, and then we incorporate the supply chain for that infrastructure, not just for the equipment itself, but for all of the activities that are required to put it in place and to operate it. And as Chuck mentioned, the funding is available not just for the equipment, but also for the planning and the development of the sites and for their operation. So we include that with the impact on the supply chains. And as you can see by that middle circle, the circles start getting bigger as we're going upward, if you will, in the economy. So we include construction and planning, operation and maintenance of the station, procurement of the equipment and its installation on site. And then there's also revenue that might be generated by the site. Retail revenue, as well as there could be advertising on the chargers themselves. There could be other sources of revenue. And then, of course, obviously the electricity that is consumed, which is also revenue. And then going to the right, there's induced economic activity, and that's the respending of those dollars that are spent on the equipment and all of the activities that are required to put it into place and to operate it on site. And those dollars flow up into the economy, and they go for all kinds of other, what they call induced economic activity, as the people who get the jobs, the job holders, if you will, for the other activities, go out and they respend their dollars in restaurants, vacations, shopping, whatever. And those account for additional economic activity, and there are jobs associated with those activities as well. Next slide, please. The jobs models and jobs EVSE itself model, they user-defined scenarios, and the user can define a scenario that is either on the state level or for any of the 9 census regions or for the US as a whole. And they specify the region of interest when they download the model, the number and capacity of the stations, their utilization, the electricity price, expenditures for all of the various pieces of equipment, and for all of the activities. And they either can specify those things which are specific for their own project, or they can use default values that are in the tool. So we have default values, but we encourage users to put in their own values if they have better data. And presumably, if they are working with developers and with communities that actually have developed these plans, they may have better data, and that's great. And those expenditures are translated into dollar flows among industries. And the model uses the US Department of Commerce's RIMS-2 input-output model. And the reason why we use that particular model is because it's a government product. It's not copyright. It's something that we can embed in the tool and without having any kind of issues related to intellectual property. So that tool, the model itself is embedded in the tool. And so that's what we use to track these expenditures throughout the economy. Next slide, please. And I'm going to focus specifically on the equipment on site. main classes of equipment are the service drop, the transformer, if you will, the meter, panel, conduit and wiring, and the charger. Next slide, please. This is a little bit more detail, which it's not as pretty on the next slide, but at least it explains. There we go. So we include permitting, engineering and design, site prep and construction, all of the infrastructure, a contingency factor. We also include shipping, we include installation, the operating expenditures, as I said earlier, electricity. There's also administrative expense, maintenance, warranties, data and networking, which is an item that is particularly relevant to EV charging. We have station operation revenue. I mentioned before that there might be retail sales, advertising, access fees. And then another important aspect is local or in-region shares. For each type of expenditure, and it could exclude the equipment or it could include the equipment, we specify what fraction is produced within the region. So for example, installation is typically totally in the region, but a lot of the equipment might not be. Shipping, maybe half. So, and we also include the in-region share for all of the other aspects. Next slide, please. So this is just an example of an analysis that we did for the state of Virginia. And this was done before the NEVI guidance came out. So for this analysis, we assumed 50 kW DC fast chargers. And obviously now, if we were to do it today, we would assume 150 kilowatt, at least for corridors. But this was looking at the target that Virginia had specified for what they wanted to deploy by 2040. We looked only at the first 10 years because I should have mentioned it. Our model only goes out 10 years into the future. And that's because economic modeling in general, with the flows among industries, it's basically, the model is basically, it reflects the economy at a particular point in time. It's based upon an input-output table that's developed by the U.S. Department of Commerce. And those flows among industries can change over time. So the farther you go out into the future, the more uncertain your forecast becomes. So we only look at the first 10 years. And in the top graph, you can see our results by charger type and location. And on the bottom graph, it's by whether we're talking about development, the jobs associated with developing the stations versus operating the stations. And as you can see, the development is constant because we assumed a constant number of stations that were going to be deployed each year. Those are the gray bars. Whereas operations increase as more stations are in operation. And you see around 40,000 jobs in 2030. And the number that over 10 years is the sum of those bars. And we show a range on the left, 274,000 to 291,000. That's because we looked at a couple of different alternatives in terms of the in-region production. But it roughly amounted to 0.2 jobs per year per charger in operation. And I believe that's the last slide. Next slide, please. Yes, thank you very much.
Great, thank you so much, Joanne and Marianne. Next up, we have Eric Wood from the, sorry about that. Next up, we have Karen Glittman from the Center for Sustainable Energy. Karen is the Senior Director, and she will dive into their new Carrot tool.
Great, thank you. And I'm hoping you can all hear me. My video won't allow me to start either. So I guess I'll just do it from behind. So thank you for this opportunity to present to you. I'm Karen Glittman. Just a little brief background bio. I've worked at a State Department of Transportation as the Director of Policy and Planning and the Deputy Secretary, worked at a University Transportation Research Center, one of 10 national UTCs, and have worked on electric vehicles since the 1990s when we were doing sort of backyard tinkering to test cold weather testing of Zebra batteries. So I've seen the full arc of electric vehicles, and it is really exciting to be at this stage where we're talking about this level of investment to really make this transition complete. So a little bit about the Center for Sustainable Energy. We are a 25-year-old mission-driven nonprofit with a single word mission, decarbonize. And we do this through the administration of incentive programs, which include 7 statewide electric vehicle incentive programs, electric vehicle infrastructure programs, solar on multifamily affordable housing programs, and energy storage incentive programs. I mentioned those latter two because the NEVI program that we've been talking about does allow for the use of those funds to deploy renewable, on-site renewable energy generation and storage if it reduces the overall cost of construction and operations of the site. So I think that's an important little tidbits there. CSC has designed and administered more than $1 billion worth of incentives for electric vehicles, and we have more than $500 million of EV infrastructure incentives under program administration. So we combined our data and experience to create the climate tech platform Carrot that I'll be sharing with you today to really help states, cities, and utilities accelerate the EV future. And I'm also going to share a specific case study of its use on a current project. And I'll also note that we have just kicked off a project with the Louisiana Clean Fuels, which is a Clean Cities coalition, and supporting their work with the Louisiana Department of Transportation and Development to do their NEVI planning as well. Next, so the CSC is also an independent nonprofit with no ties to any vendor or technology, and we have no members or donors. So I just wanted to put that out there. And next slide, please. So we've heard this $7.5 billion is headed to states, $5 billion in formula, $2.5 billion in a grant. The fundamental question that we're trying to answer here is how much charging is needed, where should it go, and when does it need to be deployed? And we use sort of a data-driven decision-making framework because we know that that advances effective, equitable EV charger placement and can align placement to meet demand and stakeholder goals. And of course, something that complies with the NEVI requirements and reporting. Next slide, please. The plan, do, check model is a useful frame for this discussion. And I'm going to focus my talk mostly on the first step, the plan step, and discuss how data connects in all 3 steps. I'll also provide that brief look at that project for the deployment of 2,000 chargers in San Diego County. Next slide, please. So data and modeling can forecast how many electric vehicles are coming and when to a state or a region. That EV demand, as we know, has been sparked by national, state, and utility incentives. So accounting for the impact of those changing variables is critical. Factoring in consumer behavior, which as we know is not driven by price alone, is also important. Our tool uses socio-technical transition theory, as we think it is the most appropriate tool to make these projections. And we have created our model to create these projections using diffusion of innovation math and science based on 5 years of data from 16 different jurisdictions around the world to provide forecasts to policymakers of new EV sales by year and the number and type of chargers required to support them. Next slide, please. The second step is to determine the location of these chargers. To do this, we determine the current situation and local priorities. And there are about 60 different factors that we have in our tool that policymakers can toggle up and down and weight appropriately towards based on their local consideration. Things like traffic volumes and patterns, the location of existing EV drivers and charging sites, the level of utility infrastructure, certainly knowing the substation that serves the area you want to place a charger is important, but understanding the capacity and any constraints on that substation is equally critical. Proximity to disadvantaged communities, any land use constraints, and of course, the all-important alternative fuel corridor. Next slide, please. A quick side note, all the assumptions in terms of how many chargers are needed to support a fleet are based on some assumptions, and making sure that you understand what those assumptions are in any tool you use, and hopefully can adjust them based on your local considerations. So it's sort of making sure you look under the hood of any model that's providing you with projection. So making sure anything from the size of the EV fleet to the percent of home charging, to the number of electric vehicles that can be serviced by one DC fast charger. All of those will provide dramatically different results in terms of the number of chargers needed, and of course, the estimated total cost. So I just want to make sure folks think about assumptions, drill into them, and make sure they fit with what you think is appropriate in your local jurisdiction. Next slide, please. So I'm going to skip over the do part, which of course is something CSE has a great deal of experience with, and really help you go to the check part. And I'm thinking there is a missing, I think there's a, there you go, thank you, into the check part. To really help you look at that real world data to help you determine if you are on or off course to meet your goals. And of course, this also helps you meet your reporting requirement. So data analysis from charging sessions, which will flow back into the entities, can help you understand how many charging sites are based on different type of chargers, the total sessions, a heat map of downtime events. NEVI does have a requirement for uptime, so being able to track that, any emissions reductions, average energy consumed per session, really helps you understand the use of chargers around your deployment. There may be some chargers that you find are only used occasionally, but they may be used during Memorial Day weekend, 4th of July, Labor Day, Thanksgiving. So they'll have critical use, but they'll be seasonal. So here's just a sample of these data. I will note that our EV infrastructure data warehouse is where all the charging data from the California program that we administer is flowing into. That's part of that requirement of that program. Next slide, please. There we go. So I'm going to show this quick example based on the active project that we have to site 2,000 EV chargers in San Diego County. Next slide, please. There we go. In this example, we've set up the Carrot EV infrastructure to create a site suitability score based on factors that emphasize, in this case, access to chargers for low moderate income groups, such as location of apartment units or low median income areas. Users can define their own suitability matrix based on their goals. And there are currently more than 60 different such criteria in the tool that users can weigh. And it is this weighting of the factors that will then flow into the tool that's the critical component. The software uses geographic information science and multi-criteria decision analysis to define what a suitable site looks like, and then it calculates that suitability score for each grid cell. And here you can see weighting of each of the selected criteria in this hypothetical example in this donut chart. So this gives you real feedback on how these weights are being applied. Next slide, please. So here, San Diego County is overlaid with almost 10,000 hexagonal cells. Each hexagon is about 0.6 miles across with an area of about 1/3 of a square mile. Brighter yellow colors in this case denotes high suitability score based on those factors we just put in, while darker blue denotes low suitability scores based on those selected criteria. As you see here, some parts of the county, particularly in the east, are not overlaid with hexagons because those areas are undeveloped. That is, there are no roads there, so there wouldn't be specific suitability. Next slide, please. And here we've just shown the suitability and just only looking at the designated alternative fuel corridors for those optimal chargers. So just sort of visually demonstrating that tool. Next slide, please. Here we've zoomed in on the top ranked hexagon. Again, it's 1/3 of a square mile across with the highest suitability score based on those factors that we just put in that were hypothetical. This is where you would want to start installing chargers first. Next slide, please. Removing that hexagon overlay allows you to examine the details of this highly suitable area. I'll note that the software does not recommend a specific site within the hexagon. Anywhere within the hexagon is good. And this allows for flexibility if specific sites are not available or appropriate for installing chargers. Next slide, please. Drilling even further down, you can see that there are a number of features based on those criteria that we put in that makes this hexagon an optimal site for siting chargers, such as a metro station with a large parking lot, a Home Depot with a large parking lot, small mall with restaurants and shops. Again, those were criteria that were ranked highly, which is why this hexagon was chosen. Nearby multi-unit dwellings. And of course, with the appropriate GIS layers, any other feature can be added. So if you want to prioritize a state park, that can be added. Obviously, it would show you a very different priority. Next slide, please. So to sum it all up, these 3 steps supported by dynamic data-informed software can assist states, utilities, and all stakeholders best deploy funds to charge the EV revolution and transparently report these efforts. As we know, markets and technologies change, and ensuring that these funds are being spent most effectively, expeditiously, and equitably requires a constant review of the data, all of which will answer the very first question posed, which is how much charging is needed, where should it go, and by when? Next slide, please. So in conclusion, I look forward to the conversation and the questions, and feel free to reach out if you have any as well. Thank you.
Great, thank you so much, Karen. And we'll be sharing speaker contact information as well with the slides in the recording. So next up, we have Eric Wood, who's a research engineer at the National Renewable Energy Lab, NREL, to talk a little bit about their EVIX suite of tools. Eric?
Yeah, thanks, Joy. No video for me either, but I don't think anyone's missing out on a whole lot there. Happy to chat with you guys today about the EVIX work at NREL. Let's go ahead and advance the slide here. So one of the things that I'll often talk about with people in conversations around charging infrastructure is trying to figure out how to make charging a superior or better experience than what people have today with gasoline. And that's really a high bar, right? So we're talking about charging that's convenient, affordable, reliable, and equitable. And so we think there's a lot of work to do. And it's an exciting topic because there's so many disparate stakeholders involved with their own unique interests in this space. So certainly current EV drivers, but really future EV drivers. Can we plan for infrastructure that's going to make ownership of an electric vehicle attractive to help increase the market and the climate impact that the technology has? Automotive OEMs are similarly invested, as a lot of their planning is geared around electric vehicles right now, and they've got very ambitious goals for transitioning their offerings to EVs. And so having a functional and sufficient charging network to support those sales is really critical. And of course, the charging networks themselves, they need to have a path for sustainable growth. The economics of running a charging network can be very challenging. And so this is a key consideration and stakeholder. We run the risk, I think, at times of overlooking the site host. But oftentimes the charging network does not actually own the land that chargers sit on. And so trying to understand what the value proposition is for a site host in providing charging as an amenity for customers or for tenants is a really important consideration as well. And then we've talked about it already today with the electric utility and ensuring that charging is well integrated with the grid is another key consideration. So on the next slide, we've got a little bit of a visual of what the deployment of charging can look like in the public space. And we've kind of tried to think about charging network deployment in this idea of coverage versus capacity, where early on in the deployment of a network, there's kind of some minimum level of infrastructure that's necessary. In some parts of the US, particularly urban areas, we're seeing good progress being made on providing coverage to charging and making charging more accessible to more people. The rural parts of the country and the disadvantaged communities are struggling much more, I would say, on having this access to infrastructure to provide a minimum level of coverage. And that's really the focus of NEVI, as we've been talking about today. But that need to get coverage out there early on ahead of demand really creates this utilization gap that makes it challenging for private investment. And again, a very good, I think, motivation for the public investment that's being made right now. But as the market matures and you see more demand for charging and more vehicles on the road, we would expect more market dynamics to take hold, where the business case becomes stronger and charging network companies can start deploying infrastructure as necessary in order to keep up with demand. And really, I think there are different situations regionally and in different parts of the US. So certainly corridors are in a very different situation right now than a lot of communities are. We tend to think of corridor needs as relatively small, but they're very expensive due to the high power requirements and the potential for the sites to be used just regionally, as we were talking about it.
Physical violence when he slapped his little face.
Hi, could we have everyone mute on the line, please? Great, yeah, so very different requirements on corridors and communities. And then throughout all of this planning, we talk a lot about public infrastructure, but the private network and home charging in particular really is foundational. Today, we believe that most EVs do most of their charging at home, but in the long term, that might not necessarily be the case. And so the significance of the public network is likely to grow over time as more people become more reliant on it, and it becomes a more reliable network. So it turns out that estimating things like coverage is I would argue, a relatively straightforward technical task. With kind of basic GIS software, a station every 50 miles, 1 mile off the interstate, that kind of idea, right? Estimating charging demand, I would argue, again, is maybe a more technically challenging thing to do. And I thought it was really good to see Karen's description of what CSE is doing in this space. At NREL, we've developed a suite of tools that are shown on the next slide here that we're calling the EVI-X suite. And they kind of look at a couple different dimensions of network planning. So, on the left side, we're thinking primarily kind of at a big picture, how many ports are necessary in a region, what kind of infrastructure is necessary, level 2, low power and high power, DC 50, which is kind of a historic type of charging, and then thinking more frequently about DC 150 kilowatt and DC 350 kilowatt as being more relevant as battery technology matures and we start seeing some of these larger vehicles hit the road as electric vehicles. And then where should those stations be located, of course, is the question that a lot of people are interested in. And then site design, really, we have this suite of tools that thinks more about, how do you develop an individual station? What are trade-offs between energy storage and number of ports at the station? What do the economics of running the station look like? And what is potential for things like on-site generation to help with your energy charges and storage really to help with demand charges. So sizing, load profiles, and then all of that feeds into our financial analysis tool, EVI Fast, which can help look at the levelized cost of charging and understand what some of the potential risks are for the charging network operators. And so all of these tools have distinct use cases, whether it's long distance travel, routine daily travel, heavy duty vehicles, or even things like ride hailing. Let's go ahead and advance another slide here. I'll take just a minute to talk about one of these tools. So this is the EVI Pro model. This is a model really oriented towards that use case that is most typical, I would say. So light duty electric vehicles, personally owned and used for routine daily travel. So this model attempts to simulate that use case and estimate the demand for charging from electric vehicles kind of at an individual level, and then start to aggregate up that demand in time and space in order to design a supply of infrastructure capable of meeting the simulated demand. I think that this idea of supply and demand, just, I'm a mechanical engineer by training, but borrowing some, economic theory is really important, right? So, and there's risk on both sides, right? So if we get in a situation where we have supply that is outpacing demand or too far ahead of demand, we really put the network operators and the infrastructure owners at risk of a lot of, financial hardship of having assets that are deployed that are not being sufficiently utilized. On the other side of the coin, though, there's risk to our climate goals and in the automotive community if there is demand for these vehicles, but insufficient supply or unreliable supply of charging necessary to meet that demand. And that has the potential to create really negative feedbacks on adoption and all of the goals that we have and the motivation behind electric vehicles. And so this idea of balancing the supply with demand is really critical. And it's difficult to do because we're talking about accelerating the supply or the demand for charging at a really rapid rate. So it's taken 10 or 12 years for the US to exceed 2 million plug-in electric vehicles on the road. But we're talking about, getting up to potentially north of 20 or even 30 million electric vehicles, just in the next 8 years or so. And so that we're expecting tremendous demand for charging, and balancing the deployment of infrastructure with that demand is going to be really critical. So on the next slide, we'll just show some examples of work that we're doing currently locally, with the state of New York. So this is a collaboration with NYSERDA, where we're deploying the EVI Pro model to try and make some estimates of infrastructure deployment necessary to meet demand for up to 850,000 zero-emission vehicles, just by 2025. So right around the corner, really. The slide here is visualizing a couple of the data sets that we're using. So on the left, some travel demand modeling from NIMTIC, looking at personal automotive travel only, and looking at the flow of traffic around New York City, including the 5 boroughs. It's a very interesting kind of graphic, right? Because it allows you to look at how these different boroughs are connected by the type of typical daily travel that you see in connections between Long Island and Queens, Bronx and Manhattan, things like that are really kind of fascinating to dig into. And then on the right, we're visualizing a large GPS data set that we're working with from a company called Wejo. This tri-state map visualizes about 100 million real-world driving trips from the region, both pre and post lockdown from 2019 and 2020. So giving us an opportunity to look at some of the effects of the COVID shutdown and how travel in the tri-state area changed during that time. On the next slide, we'll just show some preliminary results from this work with NYSERDA, focusing in on New York City and in particular, some agent-based modeling that we've done of ride hailing and the taxi and TNC industry, including Uber and Lyft in New York City. So the 3 maps of the city shown here are visualizing different scenarios for the ability of taxi cabs and TNC drivers to access overnight residential charging. On the left side, we're looking at maybe a business as usual case in New York City, where only about 15% of drivers are able to charge an electric vehicle overnight. And on the right side, we're looking at a very optimistic case where everyone is able to charge their vehicle overnight for taxi cab and ride hailing services. It's, I would say, maybe notorious in some ways that the density of New York City and the ability to get access to home charging is very challenging. And so this map kind of illustrates the impact that access to overnight residential charging could have on the demand for public fast charging infrastructure, with potentially, in a low residential access scenario, a lot of demand concentrated in Manhattan, where a lot of the ride hailing trips are happening. However, in a high residential access scenario, you look at a very different network. So the role of the public network is much smaller there. but you need a much larger private network of stations that are located in or near where the drivers lives, oftentimes in the outer parts of Queens and Brooklyn, in order to support charging while the driver is at home, either during the day or overnight. And so kind of some interesting trade-offs between the types of charging that could be necessary for ride hailing in New York City and where that charging could be located. I'll go ahead and wrap up here. So on the next slide, we're just showing kind of a snapshot of another one of our tools. So this is kind of our only tool right now that is freely accessible and on the web. This is a light version of our EVI Pro model. So if you navigate to the Alternative Fuels Data Center or just Google AFDC and EVI Pro, you should be able to find this website that allows you to access a lot of the analytic capabilities of EVI Pro, and hopefully in a simple and intuitive user interface that allows you to develop some of your own scenarios for EV adoption locally and get some quick estimates of what network size by charger type may need to be in order to support the demand that we would assume would come with a fleet of that size. So the tool allows you to look at things like residential access, charging behavior, as well as the impact of vehicle technology, whether we're looking at a lot of plug-in hybrids or a lot of long-range battery electric vehicles. And then the last slide I'll show is just an anecdote of some of the users of the tool. So this is a direct quote. So having a quick online tool that gives a ballpark estimate of charging needs is a deeply helpful service. I've witnessed firsthand the amazement when city level sustainability staff first use EVI Pro Lite. And so feedback like that, in addition to monitoring page views and activity online, is something that really motivates us to deploy these kinds of tools. And one of the things I'm kind of excited about right now is trying to take more of the internal modeling that we've done at NREL and with the Department of Energy and developing these kinds of light tools to make it more accessible and easier to run these kinds of analysis and potentially increasingly more sophisticated analysis by the general public. Certainly happy to have conversations about working directly with NREL, but there's just so much activity in this space right now that I think these kind of free self-service tools are have the potential to provide a lot of value to the industry. So that's it for me. Happy to chat with folks later today or offline.
Great, thank you so much, Eric. And I will also speak to how easy the EV Pro Lite tool is. We've used it in some of our work and highly recommend folks check out that AFDC website. And now I'm going to pass it over to Barry Carr, the Executive Director of Clean Communities of Central New York, to quickly go over a few of the other available tools to help on your alternative fuel corridor and EV infrastructure planning. Barry? Barry, you might be muted.
Hey, I am here. I am here,
We
everybody.
can hear you now.
All right, I locked up at an inappropriate time, but first, I want to thank everyone and thank Eric Woods because I didn't review this prior to the presentation, and he talked all about the EVI suite, and that is something that's very important for you to use. So this is my audible. First, of course, the U.S. Department of Energy, and more importantly, for those of you on the call, you have 6 different clean cities organizations within New York State. So there's certainly one covering your area. And when you review this, you'll see more information on it. But secondly, I want to talk a little bit about real estate. There are a lot of local real estate offices and regional groups that are part of a group called NAIOP. And I'll make certain that this goes out on the notes to everybody. NAIOP stands for the National Association of Industrial and Office Parks. those are the people who work for property owners, that's land and commercial buildings, and the actual commercial realtors. They really, really love to hear about adding EV infrastructure because it makes their property and their buildings more valuable. So I would suggest you go to NAIOP.org, NAIOP.org. There is also a real estate management group called BOMA, the Building Owners and Managers Association. There is a regional chapter of BOMA, one downstate for New York City and one upstate. Next would be utilizing NYSERDA. Here in New York State, we benefit from a strong energy office, NYSERDA. They actually have they have a section on their website that Joy has highlighted here on the slide, and it is for potential hosts of EV charging stations. And then finally, the DOE sites. So we have access through the local clean cities to Department of Energy tools and sites, most notably the Alternative Fuels Data Center. So you can see where existing stations are and then add additional stations. My final suggestion is to contact the representatives for your local utility. I note in the participants that we do have representatives from National Grid here in upstate New York, as well as Avangrid that covers upstate and downstate New York. We also have PSE&G providing electrical service in New York State, and Con Ed / Orange and Rockland. So again, thank you for everything. Thank you for your participation. And I'm going to turn it back to Joy and David for the Q&A.
Great, thank you, Barry.
Sure.
I'm going to pass it now over to David Keefe, the Clean Cities Coordinator for the Greater Rochester Clean Cities Coalition. If anybody has any questions, please feel free to drop them in the chat now, or you can raise your hand.
Joy, we do have several questions that came in earlier in the presentation. I think they've all been addressed in some fashion. Do you want me to read those, or will those just be?
Well, it looks like we have somebody who's raised their hand, Jim Stack.
Okay.
Sorry, I had to get mute off. Thank you, everyone. I'm with the Genesee Transportation Council, and we are partners with David Keefe at Greater Rochester Clean Cities. I just wanted to circle back to the earlier when Chuck was talking about the EV corridors and the interstate 50 mile within 1 mile. One of the things that New York State has noted, New York State DOT, as they're working on the statewide plan, the new law does not change any of the restrictions with regard to right-of-way, and currently within the interstate right-of-way, most commercial activities are prohibited, and there's the potential that this would be considered a commercial activity. So that 1 mile off the interstate is really critical, because that might be where the greatest opportunities are for siting stations. And as we started to talk internally, it might draw some people in to patronize businesses off the highway, which is a good thing. One exception, at least in New York State, is the New York State Thruway, because it's a toll road and has some different rules there. There's some commercial activity allowed there at the rest areas, but generally speaking, all the other interstates in New York State and presumably the non-toll roads in New Jersey would be faced with the same restrictions. So I'm hoping that they say logically where the ramp ends and meets the local roads is where we should start that 1 mile, because the ramps are part of the interstate.
Thank you, Jim. That was a great point to point that out about that commercial prohibition on the free interstates.
This is Chuck. Yeah, no, that was a great point, but I'll also even add to that where there are facilities along the corridor right now, probably very few of them, if any, actually have the power requirements that are necessary to support this. So there's another complication, which leads to your point, where the facilities are more likely to go off the exit and be available in the community as well.
Thanks, Chuck. Okay, we have a question here from Susan McSherry. Hi, Susan. How has pandemic supply chain issues affected adoption timelines in terms of added cost and or availability? Who wants to handle that one? Anybody?
Hey, this is Barry. I'll take a shot at that because I do represent a charger supplier. I can tell you, Susan, that it most certainly affects the availability. There are chips in chargers, just like there are in vehicles. And we're finding in some electric vehicle fleet projects that the vehicles are going to arrive before the chargers. So do a lot of planning. If you're going to be doing this, you should start at a minimum of 6 months before you expect the vehicles with the planning process, and ideally a whole year. So that's the cost, that's the time of upgrading the power to the facility, to sourcing the EV chargers, to installing the EV chargers. Hope that helps.
Thanks, Barry. Okay, next question. This is from Dan Alamandajan. Is that right? Any charging plans for heavy vehicles or private buses operating within New York City?
I can start, and then I'll ask Susan McSherry from New York City DOT if she's able to share any more details. But I know that in one of the applications in the NYSERDA Clean Transportation Prize competition includes publicly available medium and heavy duty charging station in the Bronx. So you'll find out more about that in the coming months once NYSERDA's made its decision.
Hi, Dan. Yeah, and we still have an active incentive rebate program with the New York City Clean Trucks program, and also the state VIP program that has funding available for heavy duty electric trucks. And we're hoping that with some of the new projects going forward on infrastructure, as Barry alluded to, there really isn't any heavy duty infrastructure available except maybe inside the fence. We have one fleet in the South Bronx, Manhattan Beer, that has 5 electric trucks that they got through the program. They were our first 5, and we've been in business for 10 years. So it's been a real slow, arc, but hopefully it will speed up as this infrastructure funding comes, into play, and there's more availability of product that's suitable to the fleets, and we're looking forward to some improvement in that area.
Thank you, Susan. Any other questions?
I guess I sent a question. I don't know if Jim Stack can answer. This is Karen Glitman, or anyone else on this. And I know we're probably a little over time. I know that there are sections in New York and probably in New Jersey, that notion of commercial activity, that they were grandfathered in to allow for commercial activity. Do you know whether federal funds can be spent at those locations? Or are those commercial activities all done through public-private partnerships using only state funds?
Karen, this is Jim. I was starting to type a response.
Okay.
But this would benefit everybody. So as I understand it, the restriction comes down to placing commercial businesses within the interstate right of way. And those would be the free interstates. So the thruway, being a toll road, already has commercial activity built in as part of the bond covenants and helps pay for stuff. So at the travel plazas, they would be able to go in. I don't believe there's any restriction on using the federal funds to support that EV charging. The key came down to where do you site? Is the siting permitted at that location? Not, it wasn't a restriction on using the funds for the charging equipment.
Okay.
It's all about what is allowed within that right of way. You know, for example, billboards cannot be within 650 feet of an interstate. You know, there's restrictions like that with dealing with the right of way.
Mhm.
Thank you, Jim. Okay, we have time for one more. This is from John Weixnar. Infrastructure is of no use if iced by fossil vehicles or non-charging EVs, that is blocking the space, I assume. New York State has a law intact, but is there any standard in the works for signs to post the law and the fines/consequences? And then there's a link to a New York State Senate bill from 2019. Any takers on this one?
This is Susan McSherry at New York City DOT. We also have a pilot going on now for 100 publicly accessible curbside EV charging stations. And yes, to your point, we've seen a lot of complaints that the spaces are iced, and it is a constant battle, but it's a constant battle with everything. It's a constant battle to keep vehicles from not parking in front of fire hydrants or no standing zones, or you know, there's just a lot of flagrant, you know, abuse of the parking. And we've been reaching out to you know, NYPD, the traffic division. They have increased you know, ticketing, but they can't be there, you know, all the time, every day, 24/7. So we're trying to you know, just watch that, and hopefully with the addition of more chargers and more EVs on the street, they will just eventually crowd out the ICE vehicles, you know, more so than the other way around. But we do try to do what we can to you know, remind traffic that they really need to keep an eye on these things, so that the pilot is successful. And you know, that's not one of the impediments to expansion, because we know that it's temporary, and or it's just, you know, the course of doing business in New York City.
Thank you, Susan. Well, that's all the time we have. Now I want to thank all of you for joining us and for your interest and your questions. And we hope this was helpful. I also want to thank Joy and her team for managing this session. They've done a great job and helping publicize it. So if you have any questions, you can direct them to info@empirecleancities.org, and these slides will be made available. And Joy, do you have any closing remarks you want to make?
No, that's great. Yeah, thank you so much to our speakers, to David, and to everyone for your participation today. We'll send out the slides as well as contact information for the speakers, as well as the Clean Cities coalitions in the region. Thank you so much.
All right. Have a good day, everyone. Thank you.
Thank you, everybody.
Okay, thanks, bye.
Attendees.